DC circuits, electrical circuit elements. So students, we are going to discuss electrical circuit elements in DC circuits. So in DC circuits, what are the main electrical circuit elements which are used? So that we will look and that we will discuss in some detail. So the first very important component or the circuit element used in a DC circuit is resistance. So what is resistance? Resistance is basically the opposition that a material or component offers to the flow of electric current. So the idea is that if I talk about electric current, so what is electric current? Electric current is basically the flow of charge, the flow of electrons. So electron will flow in a medium. Like electricity always flows through a medium. It will not flow in the air. It needs a medium. So the medium in which the electric current will flow, that medium can offer some opposition to the flow. So that opposition offered by the medium to the flow of charge, to the flow of current, that is the resistance. So different materials may offer different sort of opposition. Like good conductors of electricity, they will offer least opposition. And bad conductor of electricity, they will offer a very strong opposition. Like they will oppose the flow of electric current. And hence we can see that electric current cannot flow across insulators, across a wood. Let us suppose I have a wooden block. I can't see electric current flowing through a wooden block because wooden block offers a very high resistance to the flow of electric current. So now we are getting a feel of resistance. So resistance is a very basic property of all the medium through which electricity can pass. If electricity is passing through a medium, definitely that medium will offer some resistance. Some medium may offer a very high resistance and some medium may offer a very low resistance, or some medium may offer average resistance. So resistance means the opposition offered by the medium to the flow of electric current. So we got a feel of resistance. So the formula to calculate resistance is V upon I. So V is the voltage and I is the current. So resistance R is equal to voltage upon current. Now see, the idea is that if the resistance is very high, then for sure current flowing will be very less, because we know that if the opposition is very high, then the current flowing through the medium, it will be very less. So resistance and current are inversely proportional to each other. High resistance, like very high resistance, it will mean a very low current, inverse relation. Or I can also say very high current, it will imply very low resistance, inverse relation. So resistance and current are inversely proportional to each other. And this formula, like you have to remember, R is equals to V by I, or I can say that V is equal to IR, the very famous Ohm's law. The unit of resistance is ohms. So we measure resistance with ohms. So what is 1 ohm? 1 ohm is the resistance offered for a unit current generated by a unit potential difference. So the idea is that, let us suppose I have a battery of 1 volt, and because of which I am getting a current of 1 ampere. So the resistance offered in this case will be 1 ohm. If we look at some of the factors which affect resistance, like the opposition offered to the flow of current. So what are the factors which can influence the flow of current? So definitely material composition is one of the factor, and we can easily digest this fact. We can realize, we can see like how material composition might influence the flow of current, because we know that metals, like metals, normally they are solid. So solid metals, they in itself have free electrons, because of which they enable flow of electrons. The resistance offered by metals will be very less, because resistance in itself have free electrons. So whenever I apply a potential difference across a resistance, very easily current will flow. The resistance offered will be very less. On the other hand, if I have a plastic, so the material composition of plastic will be completely different. And we know that electric current does not flow across plastic. Hence, plastic is used as insulators. It means that the material composition of the plastic doesn't allow free flow of electrons. So the idea is very clear. We can very easily feel that material composition influences the flow of charge, the flow of current. So different materials have different resistivities which affect their resistance. So now one very important terminology we are discussing, that is the resistivity. Every material is having an associated resistivity. So there is a resistivity associated with every material. And resistivity, what it tells how material composition influences the resistance. If resistivity of a material is very high, it means that that material will offer very high resistance. And if the resistivity of a material is very low, it means that material will offer a very low resistance to the flow of current. So now it is very clear to us that any material you take, there is a resistivity associated with that material. So we denote resistivity by rho, like this rho. So this is the symbol of resistivity. So every material has an associated resistivity with it. As we can see here, resistivity, like silver have 1.59 into 10 to the power of minus 8. Copper has 1.68 into 10 to the power of minus 8. Copper has 1.72 into 10 to the power of minus 8. Then aluminium 2.65 into 10 to the power of minus 8. So as we are going down, resistivity is increasing. And if resistivity is increasing, resistance is increasing. So we can say that silver offers the least resistance to the flow of current. Silver offers the least resistance, followed by copper, then aluminium, then tungsten, then iron, platinum, magnesium, lead, mercury, carbon, silicon, glass, hard rubber. Hard rubber has a very high resistivity. Very high resistivity means it will offer very high resistance to the flow of current. So now this is very clear to us, and from an engineering perspective, we got a feel that okay, silver offers the least resistance. It means that if I use a silver conductor, it will be ideal. Why it will be ideal? Because the loss of electrical energy will be the least. But we can't afford silver wires because silver is very expensive. And hence you can see in the transmission line, we have copper wire. We prefer copper wire above aluminium wire. Why is it so? Because the resistivity of copper is very less. It means that when the electricity will flow, less resistance will be offered, and hence less loss of energy will take place. Aluminium, the resistivity is high as compared to copper. So energy loss will take place in the aluminium wire. So material composition is one of the factor which influences the resistance, the flow of current. Material composition, like we can measure its influence with the help of resistivity. Every material has a resistivity associated with it. Now the other factors which influences the resistance, so they are dimensions. So dimensions means the length and the area. So if the length will increase, definitely resistance will increase. Because if I have a very long conductor, so ultimately in the entire journey of the charge, the opposition offered will increase. So as I will increase the length, resistance will increase. This is making sense to us. Because see how resistance is offered via collisions. Because when the charge is flowing, they will collide. More the collision, more the resistance, more the opposition. Now just tell me, if I increase the length of the conductor, more distance needs to be traveled by the electrons, and hence more resistance they will face. So this is very clear to us that length, if the length will increase, resistance will increase. And if I talk about cross-sectional area, so if the cross-sectional area will increase, then the resistance will decrease. So how is it so? So what is cross-sectional area? This circle, if I am drawing, so this can be a cross-sectional area inside which the electron will flow. like to get a feel of it, you can assume it to be the thickness of the wire. If the wire, the cross-sectional area will increase, then resistance will decrease. How is it so? Just think about it. So the idea is very simple. Like see, if the cross-sectional area will increase now, electrons will have more space to travel. So number of collisions will be less. And if the number of collisions will be less, resistance offered will be very less. So if the area, cross-sectional area will increase, resistance offered will decrease. And if the area will decrease, then when the charge will flow, they will collide a lot. There will be lots of collisions, because of which I can say that resistance will increase. So in the transmission lines, we can see very thick copper wire, because cross-sectional area will be large, so resistance offered will be least. So one very interesting formula I have, rho, that is the resistivity. It is related like this, RA by L. Or to be more precise, I can say that resistance is directly proportional to the resistivity. Very high resistivity, very high resistance. Very low resistivity, very low resistance. Resistance is directly proportional to the length and inversely proportional to the cross-sectional area. So this is a very important formula for resistance. So this formula is telling how resistance is getting affected, like how the resistance is dependent on resistivity, length, and area. Similarly, we have some other factors which influences the resistance, that is the temperature. So if I talk about temperature, so definitely if I will increase the temperature, the charge, like their kinetic energy will increase, because they will like get excited. They will absorb the heat energy, because of which their movement will increase and number of collisions will increase, and hence resistance will increase. So if the temperature of a conductor is increased, the resistance will increase. Very simple logic, because see, inside conductor we will be having lots of charge, free electrons which will be moving. So when I will pass heat energy, those electrons, their kinetic energy will increase, because of which they will collide more and more. More and more collisions will take place. If more and more collisions will take place, what will happen? Automatically, resistance will increase. So I can say that when the temperature increases, resistance increases. And similarly, the next factor which influences the resistance, the flow of electrons, the flow of charge, the flow of current, that is the presence of impurities. So definitely presence of impurities also will lead to the increase of resistance. So the idea is that if there will be excess of impurities, then definitely the number of collisions will increase, because if I add excess of impurities, if I add more and more particles inside a conductor charge, they will collide more. And if they will collide more, resistance will increase. So presence of impurities will increase the resistance. So if you have to increase the resistance of a conductor, what you have to do? You have to introduce more and more impurities, then resistance will increase. If you raise the temperature, resistance will increase. If you increase the length, resistance will increase. If you shorten the cross-sectional area, resistance will increase. And if you choose a material with a very high resistivity, like rubber or plastic, resistance will increase. So now we got a very clear understanding how resistance is like factors affecting the resistance. Okay, students, now we will discuss resistor. So say resistance is a property of a medium, like it is a universal property, it is a basic property. Like whenever current will flow in any medium, there will definitely be a resistance. And what is a resistor? Resistor is a special device or a component which we use to introduce resistance in an electrical circuit. Because see, when we are studying DC circuits, it means we will be learning to design DC circuits, to analyze DC circuits, like direct current circuits. So these circuits contain so many different components. So they also contain resistors. So what are resistors? Resistors are basically electronic component. And why we are calling it electronic component? Because they operate at very low voltage. So what is the difference between an electrical component and an electronic component is that electrical component can operate at very high voltages, but electronic component, they operate only at very low voltages. So in this circuit, these small components you are seeing, so these are like resistors and they operate at very low voltage. So hence we can say them to be electronic components. So resistors are electronic components specifically designed to provide a known amount of resistance in a circuit. So it's very interesting that whenever we are designing a circuit, there are so many scenarios in which we want to introduce a known amount of resistance in a particular path. Like electricity is flowing inside the circuit. If I want to introduce some resistance in a particular line or in a particular path, that I can do with the help of resistors. So as you can see in this circuit, we have so many resistors. So all these things, so all these are resistors. So many resistors we can see. So idea is that, okay, in an electrical circuit, we can use resistors, which are small electronic components, with the help of which we can introduce a known amount of resistance in an electrical circuit. So basically, resistors are commonly used to control current. So the idea is that, let us suppose we have some sensitive components in a circuit, and we want that very less current should flow via those sensitive elements. There I can introduce high resistance, because of which a very low current will flow. So basically, with the help of resistors, I can control the current. I can control the flow of current inside a circuit. So it's so interesting. I can divide the voltage, and this division of voltage is very important. Like you will be doing lots of numericals also across it. Resistance always divides the voltage. For example, like to get an idea of it, let us suppose I have a circuit which is connected to a 12-volt battery. Now, potential difference across all the points, or the voltage across all the points, will be 12 volt itself. But if I introduce some resistance, then with every resistance, there will be a voltage drop. There will be a potential drop. So potential difference across A and this point will be different from 12. It will be less. And between C and D, it will be further, it will become more and more less. So the idea is that whenever I introduce a resistance, it will divide the potential, it will drop the voltage. So this is also a very important application, that across any 2 points, if I need less voltage, so I can introduce resistance, which will help us to basically divide the voltage or drop the voltage. Similarly, resistors perform other functions in electronic circuits. Like it has so many usage. Like if I use resistors along with capacitor or inductor or RLC circuit, you might have studied. Like you might have definitely seen RLC circuits: resistance, inductor, capacitance. And if it is connected with an AC source, alternating current source, then their resistance has a different application. So resistance, or this resistor, has got several applications. It will depend on the context. So like this is one of the resistor which you can definitely see in any circuit. Like if you open any component like appliance, definitely you will see so many resistors. So this is a resistor. And symbolically, like when you will be solving numericals problems, there you will see this symbol. So this is representing resistor or resistance. So like these are some different types of resistors which are widely used in circuits. Like we have this carbon composition resistor, then carbon film resistors, then we have metal film resistors. So definitely you might have seen all these. Then we have metal oxide film resistors, then wire wound resistors, thermal resistors, fusible resistors, carbon potentiometer resistors. So the idea is this of this carbon potentiometer resistor is that here we can like rotate it, so we can vary the resistance. So it is a kind of a variable resistor. Like it's a potentiometer resistor, means we can vary the resistance. So it's very interesting. Similarly, we have rheostat resistor. We can also vary this. Like here, like we can move this, because of which we can alter the length. And we know that as the length will increase, resistance will increase. So this, as it will move far away, resistance will increase. And if it will get closer to this end, resistance will decrease. So we can control the resistance. Similarly, we have trimmer resistors, then surface mount resistors, wire wound potentiometer resistor. So this is also a variable resistor. So these are like different types of resistors which are widely used in like circuits. And we can see like 1/8 watt resistors. So watt is the unit of power. So power is rate of doing work done upon time. So we measure it in watt. So 1/8 watt resistors we have. Then we have 1/4 watt resistors. Then we have 1/2 watt resistors. Then 1 watt resistors, 2 watt resistors, and 5 watt resistors. So as you can see, this 5 watt resistor will be very powerful. Like it can offer a very high resistance to a like very high flowing current. And if the current flowing is very small, then we can use this tiny resistors, very small resistors. Okay, students. So the next important electrical circuit element in a DC circuit is capacitance. So like capacitance is also an inherent property. Like, so what is capacitance? Capacitance is the ability to store electrical energy or the ability to store the charge. So we know that whenever current flows, it carries charge because the flow of charge is the electric current. Now, the material or the medium through which the current is flowing, that medium can hold a charge, or there can be some other medium which we will discuss very soon that can hold a charge. So we have different mediums which have different capacity to store the charge. If the capacity of a medium to store the charge is very high, we say it is having a very high capacitance. So capacitance is a ability to store charge. So more, if a medium can store a very high amount of charge, then that medium will be having a very high capacitance. And if a medium has a low ability to store charge, then that medium will be having a low capacitance. So capacitance is the ability to store charge. So we write something like this: capacitance is equal to charge upon potential difference. Because see, whenever we apply a potential difference, current will flow, charge will flow. Now, if that charge flows through a particular medium, if that medium can store that charge, then we will say that, okay, that medium is possessing some capacitance. And from the formula, we can see that C is directly proportional to Q. So if charge is very high, like the stored charge is very high, then the capacitance will be very high. And if the stored charge will be low, capacitance will be low. So the capacitance is the ability to store charge. And capacitance is measured in farad, or Faraday also we call it. So we represent it with F. So 1 farad will be like if I give a voltage of 1 volt and if 1 coulomb charge flows. So if 1 coulomb charge is stored inside a medium which is connected to a 1 volt battery, then I will say the capacitance of the medium will be 1 farad. Now, basically, if I talk about capacitance, so we have parallel plate capacitor, very famous. Like we can have cylindrical capacitors also, that we will see very soon. So here, basically, I am having two metallic plates. Like two metallic plates means they are conductive plates. Conductive plates means they are good conductor of electricity. Charge can very easily flow inside them. So I have two plates. They are separated with a distance, and in between we basically have filled it with a fluid or with a dielectric. So dielectric can be any medium within this plate. So that can be air also, or that can be a particular gas like a hydrogen, oxygen, or it can be any fluid also. So dielectric can be anything. So usually dielectric acts like an insulator. So the idea is that if I have two metallic plates separated by a distance, so definitely this dielectric will act like an insulator, because now current will not flow in this region because current needs a path. So here we are breaking the path because we know that air is not a good conductor of electricity, like charge cannot flow in air. So what will happen? This insulator, it will basically stop the current, because of which charges will get accumulated on the surface of this plate. Because see, whenever I will apply the potential difference, it is very clear to us that current will flow, charge will flow. Now, when charge will flow here, like plus Q, they will not be able to like flow further because of this insulator. So they will stuck here. So they will accumulate here. So this accumulation of charge, and similarly here negative charge will accumulate because it is at the negative terminal. So minus Q charge will accumulate here because they will not be able to like pass this insulator. That is not possible. So this accumulation of charge is the capacitance. Now this dielectric will influence the amount of charge stored. Like if I use a different dielectric, like if I use a different medium like oil or honey or milk, pure water or oxygen gas or nitrogen gas or helium or just normal air, the capacitance will be different. The amount of charge stored will be different. But now like we got some idea, and also this distance will also influence this distance. So this distance and this permittivity, like this dielectric will be using, that we will see very soon. That will influence the amount of charge stored. But it is very clear, we got to feel that okay, medium can store a charge. So how it is possible? This is one example wherein we have two metallic plates which is separated with a distance, like they are separated by an insulator. Now, when the electricity will flow, they will the electric current will not be able to pass the insulation. So they will accumulate on the plates. So we call it like accumulation of charges. So that is the capacitance, the ability to store charge. And here we are telling the ability to store energy because charge is holding the energy. So if charge is getting stored, it automatically means that energy is getting stored. So capacitance is an inherent property. Every material has got some ability to store charge. So that is capacitance. If the material has a high capability to store charge, then its capacitance will be very high. And if the ability to store charge will be less, then the capacitance of that material will be less. So every material has got some capacitance associated with it. So it's a inherent property. Now, what is a capacitor? Capacitor is basically an electronic component which we introduce in a circuit. So which basically converts the input electrical energy into electrostatic energy as output. So the idea is that these capacitors, they can store energy. So they act like energy sources. So the idea is that they can provide some impulsive energy when needed. Because see, so in capacitor, there is a concept of charging and discharging. So whenever we like pass a potential difference across a capacitor, the capacitor will charge. So it will store energy. Now, whenever needed, that energy can be utilized. And there are so many scenarios where this stored energy will be used. Then we call it like discharging of capacitor. So capacitor will discharge. So as you can see here, we can see so many capacitors. Here we can see so many capacitors. Like this is not the capacitor, but like this. So these are like capacitors. So now we got to feel like, okay, capacitors, basically these are electronic components which we can introduce in a circuit. And what is the main role of these components will be like they can store energy. So they can get charged, which means that they will store energy and they can supply energy to a particular path to which it is connected. So let us suppose if the power goes off, so to avoid abrupt like on and off, because we know na abrupt change in electric field will generate magnetic field, like EMF will be generated. To avoid such scenarios, so whenever power goes off, this capacitor will discharge. It will take some time to discharge, so it will supply some energy so that the power off will be not abrupt, but it will be steady, like it will be in a slow motion in a continuous manner, and it will not be abrupt, because of which we can avoid generation of reverse EMF and all that thing. So this is just a very basic application. This capacitors has got lots and lots of applications that definitely we will explore in some other lecture. But now we got a feel of capacitors. So like these are some very important capacitors which are used in circuits. You might definitely have seen some of these. Like this is a paper capacitor. This is a polystyrene capacitor. So this is a bipolar capacitor. Then we have something called electrolytic capacitor. Then we have this polycarbonate capacitor. Then we have this polyester capacitor. Then we have this Maillard capacitor, silver mica capacitor. So this definitely you might have seen in some of the circuits like this and this. And ceramic capacitors, definitely you might have seen. Tantalum electrolyte capacitors. Then we have this feed through capacitors. Then we have this trimmer capacitors. Then we have this variable capacitors. So as the name suggests, here we can change the value of capacitance. Now we also got one idea that if capacitance is high, the amount of stored energy will be high, because we saw now whenever we introduce capacitor in any electrical circuit, it will basically store energy. It will store the electrostatic energy. So if the capacitance is very high, it means that the stored energy will be high. And if powerful components are connected to that path, then it will be enough. Like we need powerful capacitors so that when the power goes off, it will supply high energy to those components to avoid damage or reverse EMF. So these are like capacitors. Okay, students. So the next important electrical circuit element in a DC circuit, so that will be the inductance. So the element will be inductor, but first we will discuss the property, that is the inductance. So inductance is an inherent property of any medium. So what is this inductance? Let's first understand this. Then we will discuss about inductor, which is the circuit element in a DC circuit. So if I talk about inductance, so it is the property of an electrical conductor by which change in electric current through it induces the electromotive voltage in conductor. So it's very important phenomena. It's very important, and we have to feel it, like what exactly is the meaning of inductance. Okay, so let us suppose I have a material. So like this cylinder you are seeing. So this cylinder is basically a electrical conductor. So now what I am doing, basically I am having a wire which is rolled across this conductor. And usually like this will be a naked wire, like the outer insulation will be removed. Outer insulation can be there, but to be more precise, like so that we can get a good feel of it, we can remove the outer insulation so that we will get an idea that, okay, when that wire will come in contact with this cylinder, since this cylinder is a conductor, electric charge may flow across this electrical conductor, this cylinder. Okay. So now see what will happen is, if we pass an alternating current, like not direct current, but see, like we are discussing DC circuit, and in DC circuit, why we are introducing alternating current? So that shouldn't be the case. That I totally agree. But for now, let us assume an alternating current to get a feel of it. Then we can correlate it with DC, its application with DC. So if I have an alternating current, I know the property of alternating current is that for some time it will be having one value, for other time it will be having a different value, like high voltage, low voltage, high voltage, low voltage. So current will not be constant. Okay, so very important discussion I am making. Like in DC circuit, the idea is that with time current will be same, the value of the current will be same, it will be constant. But for an AC current, it will be different. Like it can be a sinusoidal, or it can be a cosine wave or a cos wave. So like let us suppose it is a sinusoidal wave. So we can see with every time instance the current will be different. So this is the AC current. So now the point is that when we have AC current in which the current is changing. So if the current is increasing, like here we can see the current is increasing for some time. So if the current is increasing, what will happen is then a voltage opposing that change is created by the magnetic field of the coil. So let us feel it, like what exactly is happening. So there is a basic property which says that it will try to oppose any change. So what I'm trying to say is that there is a basic property which says that if current will increase, then it will try to oppose that increase. If the current will decrease, it will try to oppose that decrease. Okay, like we have inertia in mechanics, like we have studied about inertia. So what inertia does is that it tries to oppose the change of state. Like if a body is in rest, if we try to move, initially we have to put some effort, because inertia tries to resist. Inertia says that let it be in the rest. I will not allow you to change its state to the motion, inertia. Similarly, here also in this electrical circuits, whenever current tries to increase in a conductor, there is some phenomena like inertia in the mechanics. Here, there is some phenomena which tries to oppose the increase in current or oppose the decrease in current. And that phenomena we can like link it with inductance. So just like inertia we had in mechanics, which opposes the change of state of motion. In electrical circuits, we have inductance, which opposes the change of state of current. Like if current tries to increase its value, inductance will like oppose it. And if the current tries to decrease its value, inductance will oppose it. So now the question is how inductance will oppose is, so we know that whenever current flows, magnetic field, so this we have already studied that whenever current flows, so there is a magnetic field or magnetic flux around the coil. Okay, so if the current is flowing in this direction, magnetic field will be like this. So it will be like cross. So here it will be cross and here it will be dot. Cross means it will be going inside, dot will be coming outside, something of that sort. So the idea is that, so if current is trying to increase, it means magnetic flux will increase, like magnetic field will increase. So it will generate a reverse EMF, or it will the coil, the inductance, it will generate a opposing magnetic field, which will try to reduce the increasing magnetic field. And if it will try to reduce the increasing magnetic field, if it will automatically oppose the increase of current. So this is how it works. So the idea is that whenever the current flows, there is a magnetic field associated with it. If I increase the current, magnetic field will increase across the conductor. And if I decrease the current, magnetic field will decrease. So the idea is that if there is an inductor present, what inductor will do, if current, like if current is trying to increase, like if I'm trying to increase the current, if I'm trying to increase the magnetic field, this inductor or this the inductance, the basic inherent property, what it will do, it will generate a reverse magnetic field which will try to oppose the increase in magnetic field, because of which I will face some opposition. I will face some opposition in increasing the current. Similarly, when I will try to decrease the current, magnetic field will decrease. So this inductance, it will generate a magnetic field which will try to increase the magnetic field. So opposition will be created. Okay. So now we got a feel that resistance, we have already studied, resistance opposes the flow of charge. Similarly, inductance is not opposing the steady current. Inductance is not opposing the constant current, but inductance opposes the change of current, change of magnitude of current. Like if you try to increase the current, then inductance will come into picture. If you try to decrease the current, then inductance will come into picture. So inductance acts like a resistance of AC. So whenever the current is changing, the opposition to a changing current is the inductance. Like opposition to the constant current is resistance. Like if I am having a constant current, the opposition to that is the resistance. Similarly, opposition to the AC current or the changing current, that is the inductance. So inductance is an inherent property of a material. Every material has got some inductance. Some material is having a very high inductance. Some materials might be having very less inductance. So now it's very clear that if I have a material with a very high inductance, it means that it will strongly oppose the flow of AC current, because whenever current try to increase or decrease, it will oppose that increase or decrease. So now we got a feel of it. Inductance. So inductance is an inherent property of an electric conductor by which a change in electric current through it induces the electromotive voltage in conductor. Now the formula for inductance is phi by V. So here phi is the magnetic flux because of some current I, and V is the potential difference. This formula says that inductance is directly proportional to the magnetic flux. If the magnetic flux will be very high, inductance will be very high. It means that the conductor or the material through which the current is flowing, that will generate an opposing magnetic field of a very high intensity, so that it neutralizes the effect. So inductance is directly proportional to the magnetic flux. So if current is trying to increase, it means magnetic flux is trying to increase. So inductance will also increase. And when inductance will increase, it will generate an opposing magnetic flux, which will try to neutralize the effect. So in short, inductance opposes the change of magnitude of magnetic flux. So inductance is measured in Henry. So Henry is the unit to measure inductance. And like this is the symbol. So in electrical circuits, like when you will be solving problems, there you will be, if you see something like this, you understand that, okay, this is an inductance. So this is basically a resistance of an alternating current. Okay, now let us look at inductor. So inductor, basically it is an electronic component using which we can introduce an inductance. So inductor basically converts electrical energy into magnetic energy. So the idea is that inductor also stores energy. Like we saw, capacitor used to store energy. Whenever we pass potential difference across the capacitor, it used to get charged, then it used to get discharged. Similarly, inductor also, whenever you will pass some potential difference across inductor, so the electrical energy that will get stored in the form of magnetic energy. And once the power goes off, like if you remove the voltage source, this magnetic energy can later on be converted into electrical energy. So in practical applications like in electronic circuits or electrical circuits, what is the role of inductor is to basically store electrical energy in the form of magnetic energy, so that when the power goes off, this stored magnetic energy can later on be used as electrical energy to avoid reverse EMF. So this is like one application. Apart from that, many more applications can be there. And also one more very interesting application we can feel is, let us suppose we have some appliances which work or which operate on AC current. So there, this inductance or this inductor will act like a resistance, because we know that inductor opposes the AC current. So if I want to oppose the AC current, because I know that in our like house, we get 250 volt AC current, for example, or 230 volt AC current. If this is the scenario and I want very less current, there I can introduce some very powerful inductors. So they will like act like a resistance. They will like bring down the value of the AC current. And these are like some inductors which you can see in circuits. So this, like you might have definitely seen. So this and this and this might also you have seen. Like we have transformers, we have generators in circuits. So they are like they use inductors in them. So until now, like we have studied about resistors, capacitors, and inductors as electrical circuit elements in DC circuits. Now we can also categorize circuit elements as active elements and passive elements. So what are active elements? Elements which supply energy to the network. So basically, active elements are those elements which don't consume or which don't dissipate the energy, which don't waste the energy, which either supply the energy or which either provide a passage to the flow of energy or to the flow of current. Like switches, what switch will do? Switch will like just provide a passage. So switch will never consume energy. So all those elements which can either create energy or which can just help in the passage of electrical energy, like which will never consume electrical energy. So those are active components. So all the voltage sources, because all the voltage sources generate energy, they generate electrical energy. Like we have batteries, DC generators, these are active elements. All the current sources like photoelectric cells, metadine generator, so these are active elements. So if I talk about active components, so transistor is an active component. because transistor acts like a switch. It does not consume energy. It will just help in the flow of energy. Integrated circuit. So integrated circuits also, they act like switches, because what IC will do, like they will like just activate some pin. So all those pins which got activated, like current will flow only there, something like that. So integrated circuits are also acting like switches, or like they are just controlling the flow of current. So they are not like dissipating or wasting the energy, and hence they are active components. Now LED. So how can LED be a active component? So the idea is that, see, LED, what it does now, it converts the electrical energy into light energy, but it does not dissipate the energy, it does not waste the energy, because it is converting it into the light energy. So it is utilizing that energy, and hence we can say LED is an active component. And diode. So diode also, like, they control the direction of flow of current. Like with the help of the diode, I can change the directions of current, and like there are so many applications which you will study later on. But like diode also, they don't dissipate energy. So it means that whatever incoming energy I am having, the same outgoing energy I will have. In transistor also, whatever incoming energy I am having, the same outgoing energy I will have. In integrated circuits also, whatever incoming energy I am having, the same outgoing energy I will get. No heat, no energy loss will take place. In LED also, no energy loss is taking place. It is just getting converted. And similarly, we have passive components. So what are passive elements? Elements which dissipate or store energy. Like elements which either waste energy or dissipate energy, or they store energy. Like they don't convert, like they store energy. So these are like passive elements. Like we have resistors, inductors, capacitors. So these all are passive elements. Like resistor, we already know, because resistor, it opposes the current. It means that definitely resistor will like dissipate electrical energy. Like it converts the electrical energy into heat energy, which gets wasted. So resistors. Then we have capacitors. So capacitors also, they store the energy. Like we have already seen, capacitors convert the electrical energy into electrostatic energy. They store it. Inductors we have already seen, they convert the electrical energy into magnetic energy. They store it. And we have transformers you will study in great detail later on. So there you will see that, okay, transformers also, they basically store energy. So passive element. So now the difference is very clear to us, that if a element or a component, it is either generating electric energy or it is just supplying, then it is active. No energy loss will be taking place in the active component, and no storing of energy will be taking place. On the other hand, passive components, they will be either storing energy or they will be dissipating energy. For example, if I introduce a bulb in a circuit, so bulb will be a passive component, because definitely bulb is converting electrical energy into light energy, but bulb is also dissipating lots of energy in the form of heat, because you see a bulb, it gets heated up.